Hello Fitsies! Today we're going to be talking about direct variation, also known as direct variation. I just put a weird die on the direct instead of direct. Two variables, x and y, show direct variation, provided that y is equal to ax. A cannot equal to 0. Notice here, remember from a couple days ago, we did y equals mx plus b. Similar thing here, except the b will be 0, always. The b is always going to be 0. So it shouldn't be plus 2 or minus 5 or anything else. You should only have y equals some number, some constant times x. The number a is called your constant of variation. We will read this as y varies directly with x. Y varies directly with x. That means all I have to do is one multiplication to x in order to get whatever y is. So example 1, tell whether the equation represents direct variation. If so, identify the constant of variation. So in order to do that, I'm always going to get y by itself, and then I'll see, does it match up with this? Again, get y by itself. You have to. So in order to do that, I'm going to subtract 4x and subtract 4x. And these will cancel out, so I have 5y is equal to negative 4x. Next thing, if this was not a variable, in order to get y by itself, I would divide by 5. So I'm going to do that here as well. And I get y is equal to negative 4 over 5x. So, I don't know why I drew that line. So I have y is equal to that. Does that look like direct variation? Well, yes, because it's not plus 2 or minus 5. It's just y equals that. So because that's a yes, I'm going to identify the constant of variation, which for us is negative 4 over 5. That is your constant of variation. Same thing you did for part B. If you'd like to press pause while you solve for y on your own, and then you can check your work with my work and see if we match, or you can just follow me now. Subtracting 2x on both sides, I get negative y is equal to negative 2x plus 3. Then I'm going to divide by negative 1, divide by negative 1, divide by negative 1. Y is equal to 2x minus 3. Is this direct variation? No, it is not, because of this minus 3. If this wasn't here, I could say yes all day. But no, it's not, because it's minus 3. If it's plus 3, plus 5, plus a half, minus a half, doesn't matter. As long as there's plus something here, it is not a constant. I mean, it is not an example of direct variation. Okay, so the next thing that they would like for us to do is to graph these equations. So they're telling us already that they're direct variation, and we know it's true because this is not plus anything or minus anything. It's just y equals 2 over 5x. So for us, my constant of variation is 2 over 5, and that's the same thing as the slope. Your y-intercept, so actually I'll just label this as slope, is 2 over 5. And then your y-intercept, just to be consistent, is 0, 0. For direct variation, the y-intercept is always, always, always going to be 0, 0. So remember, your y-intercept, the b, is where you begin, and your slope is where you move. So because this is positive 2, I'm going to go up 2, and I'm going to go right 5, because it's rise over run. So for here, up 2, 1, 2, 3, 4, 5. And then you'll use your rulers to connect your dots. That's horrible. Believe it or not, I actually used a ruler for that. So you'll use a better ruler and connect your dots, I reckon. But you can pretend like mine is just the most beautiful line in the whole wide world, and I'd appreciate you for it. There you go. Only thing left to do here is to label it. And this one is y equals 2 over 5x. So the next one looks a little bit different, but it's really not that deep. Another way to look at this is negative 1 over 2x. Because remember, if they don't give you a number there, it's just a 1. So I can tell now that my slope is negative 1 over 2. And my y-intercept is always, all day, every day, going to be 0, 0. So from here, because it's negative, I'm going to go down 1 and right 2. There's only one negative sign, so I'm not going to go left. Just down 1, right 2. Down 1, right 2. Then, just like you did for the last one, I'm going to have you connect your dots in a nice straight line. And by straight, I mean not with that extra piece that I have here. And label. Y is equal to negative 1/2 x. Not so bad, right? Right, misfits. So the next set of directions, or directions, tells you to, so they first tell you the graph of a direct variation equation is shown. So we know that this is true because it goes to the point 0, 0. Yes, it's direct variation. They would like for me to write the equation of this line. So remember y equals ax. Well, I just need the slope then. So I need to know what the a is. And remember, it's rise over run because a is the same as m, or slope rather. So here's a good point because I know it goes through 0, 0. And here's another point. So give me directions. I need the rise over the run. So I'm going to go up. Let's change colors to make sure that you can see it pretty well. And you're going to rise 1, 2, 3, and then you're going to run 2. So rise over run. So for me, because I went up 3, and then I went right 2, my slope is 3 over 2. So my equation is going to be 3 over 2x, because my a, my constant of direct variation, is 3 over 2. The next thing that they ask us to do is find the value of y when x equals 14. So y is equal to 3 over 2 times x equals 14, so plug in the 14. I'll put this 14 over 1 because I like to cross cancel. So 2 becomes 1 and 14 becomes 7. So y is equal to 21. Good stuff. I know you're loving it. Direct variation, also known as direct variation. Number, doesn't have a number, but you know what we're trying to do here. This next one says, explain why C varies directly with D. Why C varies directly with C. So why C is equal to some number A times D. Well, if that's true, then that means all I should have to do is multiply D by some number, some constant of variation, which we call A, every single time, and I should get the same answer. So the question is, what can I multiply this by? What's the D for all of these in order to get these numbers? Well, we can do this by setting up kind of an equation. $25.77, because that's the C for the first one, should be equal to some number A times D, the number of DVDs, which for us, for this first one, is not D, but it's 3 for the first one. Let's write that actually. Now, how would I solve this? Well, I would divide by 3 and divide by 3, and I would get that A is equal to 2577 divided by 3 is 8.59. Now, if when I set up each of these equations, I get the same $8.59, and that means that is going to be my constant of variation. It means it's constantly going to be $8.59. So check it out for 51.54, because that's the C for the next one. Does that equal the same A times 6? So divide by 6, divide by 6. A is equal to, check it out in your calculator, $8.59 yet again. So if it works for the next one, it works always. Another way to do this would just be to multiply 9 times 8.59 and check in your calculators to see if you get 77.31. Pause, do it. I'm going to pretend like you did it. Or you can also just set up the equation and get the same thing. But yes, it does. Let's show it. 77.31 equals A times 9. Divide by 9, divide by 9. A does in fact equal 8.59. We have proven it. We've shown it. It checks out. So lastly, write the direct equation that relates the direct variation equation that relates D and C. So C is equal to AD is what we said, which means C is equal to, we found that the A was constantly 8.59, so 8.59D. There it is, direct variation in a nutshell. Hope that you enjoyed it as much as I enjoyed making it for you. You all have a good day, and I'll see you in class.